So it's a great honor and a pleasure to be here. Thank you so much for inviting me to ASC 2019. And many thanks to Hala and an amazing, amazing team that she has for organizing this wonderful conference. And kudos to all of you who participated. I mean, in my eyes, you're all winners for being here and for participating. So excellent work. And with people like Hala on your side, I'm giving you hope. I think that's a key ingredient to succeed. So my talk here is how deep learning is transforming or shifting digital economies. And I'm going to share my thoughts on these 4 topics: growing impact of AI, what is AI, machine learning, or deep learning. These terms are used synonymously, but technically there is a difference, so hopefully you will get that. How to get started with AI. There is so much that you can leverage from the open source software that's out there, and so hopefully I'll be able to point you in the right direction. And finally, my personal favorite, AI ethics and AI for social good. So AI is making a profound impact on digital economy or economy overall. It's changing the way we work, we play, we learn, and we live. And all of these verticals that you are seeing are either already digitized or on its way to be digital. When it's digital, it's going to generate data. If it's generating data, that means it's amenable to AI. So let me ask a quick question. How many of you are using AI? I would say all of you are using AI if you have a smartphone. If you have a smartphone, you are doing Google search. You're saying, OK, Google, you're using Google Maps, Siri. You're all users of AI, or deep learning, rather. So if you look at the first vertical here, it says Smart Assistant. So that's Alexa or Google or Siri. That's pretty much a lot of you are using. Chatbots. So these 24/7 bots that are giving you fashion advice, or if you want to order pizza from Pizza Hut, that's all powered by AI. And your recommendation systems that based on what you liked previously, that's all, again, AI. So I'm going to be sharing some use cases that my team works with our partners. So I'll share some of the use cases with AI in health and finance and retail, et cetera. So again, as I mentioned, that AI is making a huge impact. And let's share some of these big numbers that the analysts are reporting. So the first one here says that this is a report by McKinsey Global Institute, and they say by year 2030, $13 trillion would be generated by AI. However, the adoption is at very early stages. So 46% of the Gartner did a survey, and 46% of the companies surveyed said they have a plan for AI implementation, but only 4% have actually implemented it. There's been a lot of talk on job replacement. So there's a lot of hype, some of that well-founded, some of that not. And so another report by McKinsey says that 400 to 600 million jobs would be displaced by AI automation. On the flip side, the same report says there will be even more jobs created by AI. Now, what kind of jobs would they be? That we don't know. Some of these we don't know what jobs. So just yesterday I was reading this article which says that in south of India, this young man, 21-year-old man with very little education, has created a business for tagging data, annotating data. And by doing that, he has employed a bunch of teenagers, and he's basically serving customers all over the world. And so these kind of jobs that we don't even know yet would actually be possible because of AI. So AI has been around, and deep learning specifically, has been around for decades. So why now? Why isn't the spotlight now? I don't know if you probably saw the Turing Award winners. Turing Award is equivalent to the Nobel Prize for computer science. That was announced day before yesterday. And it went to 3 people, Bengio, Hinton, and Lee Kun. And this was for their work that they did 30 years ago in deep learning. So again, why now? The work has been around. What made it possible for AI to be used now? So number one is the data. There is so much data that's available right now. And by 2020, there will be 50 billion devices, 200 billion sensors. All of that together is going to generate a lot of data. Now, why is data good? Because it's the data that's used for training your models, and the better the models are trained, the more accurate they will be, and so on. So data is number one. Number two, paved by Moore's law with all these architectural innovations, the hardware has become much, much cheaper. Something that cost, say, $1,000 in '95, 10 years later is 3 cents. So now compute is available, your data is available, but the biggest breakthrough came from these algorithms, these deep neural networks that I just mentioned about the award that was given. So what were these breakthroughs? This is sort of important to know. So how did it become the algorithm? What breakthrough was there? So what happened was that the machines, accuracy for machines started to rise very rapidly. And I'll tell you why, what factor was that. But just, it's important to understand that the machine accuracy for both image and speech started to rise so rapidly that it superseded humans' accuracy for both of these. And if you see these charts here, they are basically showing the decline for error. The y-axis has the error rate. And it's declining both for image and speech until it matches human, and then it exceeds that. So you will see that this trend started around year 2009. And what happened in 2009 was some researchers in Stanford, they realized that these graphics processors, by the virtue of multi-parallelism, were able to train these very complex models. And by doing that, it led to accuracy. And now deep learning is used in all of these applications. Some of them are listed here at the bottom. So I'm going to touch upon some of these use cases that my team has been working with in various segments to give you a flavor of this. So Novartis is a huge, big pharmaceutical company. And they had to analyze these very large images. And so my team worked with them, and we basically optimized TensorFlow, which is Google's framework. And essentially, we reduced their training time for drug discovery from hours to merely minutes. And by doing that, they were able to run their experiments much faster and leading to faster drug discovery time. Here's another example in the health case, but it's slightly different. So I was in China not too long ago, and a lot of discussion is happening around the fact that there are very few healthcare professionals. Okay? So in order to combat that, this is a very simple example where this handheld ophthalmic device was enabled with some deep learning technology. And they were able to detect a lot of eye diseases such as diabetic retinopathy. And this is in an attempt to eradicate blindness. So we have dozens and dozens of cases in detecting skin cancer, radiology, all in the health department. So this is an example in finance. I met so many financiers and bankers during this conference, so this will probably be of interest to you. So this is an example of detecting fraudulent credit card transactions. In this case, it's with China Union Pay, but we also worked with MasterCard and many other companies where deep learning is being used to essentially increase the accuracy and coverage for fraud detection. This is something that we use within Intel. The process of silicon packaging it's very complex and time-consuming, and we use deep learning to detect cosmetic defects, and we automated that and increased 70%. So I'm trying to cover use cases from all different scenarios, and as I mentioned, we literally have hundreds of them. Taboola is world's largest recommendation engine. And they have like over 1 billion users per month, and they have about 360 billion recommendations. And all of that is again, we provided them speed up. My team did optimization, and we were able to do. So these are some of the use cases. And I have some more in the next few sections. Now let's talk about what is AI, ML, and DL. And Salam, you had asked me yesterday about that. So I have a slide just for you. And I'll tell you when you were asking me how it works. So I was like, OK, I'll put that in there. So hopefully that will be useful. So let's get this terminology correct. As I said, what is AI, what is deep learning, what is machine learning? And it's being used very loosely and synonymously. So let's first say, what is artificial intelligence? So that involves machines performing tasks that are characteristic of human intelligence. But let me make something very clear. Right now, the stage that we are in, these tasks, these deep neural networks, they are performing, or AI is performing tasks to a very specific thing. It does not have common sense right now. What we call artificial general intelligence is decades, if not hundreds years away. So these killer robots, they exist only in movies. There's a lot of hysteria and panic over that, but probably unfounded. But there are issues, and I'll talk about that in a bit. So machine learning, now artificial intelligence is the global, all of this fits into artificial intelligence. What is machine learning? Machine learning is a subset of artificial intelligence. And as defined by Dr. Andrew Ng, who, by the way, is a pioneer in this area, and I've had pleasure of listening to his lectures, and I recommend you to check it out in Coursera. So the way he defines it is that it's a science of getting computers to act without being explicitly programmed, which means the learning, right? It says machine learning. So there is this learning aspect that these machines are learning on their own. You haven't told them to do exactly what to do. And then deep learning is a subset of machine learning, and that involves a lot of data and neural networks. And this is the slide that I was talking about. So I've tried to simplify it, but there are two concepts, major concepts in deep learning. One is training, and the other is inference. In this case, the job of the deep neural network, which is the center, these neurons, the circles, and then you have interconnects with weights. So that's the deep neural network in the middle. The job of the deep neural network is to classify the input images that are coming in, into one of these three categories. In this case, it's either a human, or a bicycle, or a strawberry. So these input, this data that's coming in is labeled. That means it already knows what this is. And so in this example, a bicycle is fed into this deep neural network. It goes in, and the model, first time, incorrectly, because it doesn't know what it is, it incorrectly identifies it as a strawberry. Now, this information is propagated back, this error, propagated back into the deep neural network. The weights are adjusted so that the next time this image is passed on, it will identify it correctly. So this part of training goes on and on. Lots of labeled data is tagged data is fed into this model until it reaches the desired accuracy. Once that happens, your model is already trained. And then you're going to use it for inference, which is the second set. So the training involves a lot of compute power, and that's typically done in data centers. Inference, however, the second part, that can be done on your smartphone, or of course it's done in autonomous driving, etc. Okay, so I hope you get these two concepts clear, because this is the basic of deep neural network, which is a subset of machine learning, which is a subset of AI. So an engineer in my team had a baby girl last week. I sent him flowers, these very flowers. So being an engineer, what does he do? He takes a picture of that and runs it through a model, and then he sends me that I ran it through the model, this model, and it didn't identify, so I did this and I did that. So I said, well, thank you would have been okay, but okay, I'll take that. But then I thought this is a very good idea to show this here, that I have a very short video, 1-minute video. And I will explain what the video does. But my point is that there are all these models. He used a TensorFlow model, which is already available. So anybody could actually take a picture, run through this model. You have data sets that are also open source. So, so the first thing he did was he ran these very flowers that I sent to him, and he ran it to image recognition model. And he found that it said it's a vase. It did not identify the flowers. And why was that? Because this model was trained using ImageNet, which is very popular and open source. It did not have the flowers category out of 1,000 categories. So then he ran it, trained it, which took just 5 minutes to train it with a data set which has flowers. And this time, using the same model, the image recognition model, it identified it as a rose. Then he went one step further, where he used an object detection model, which built a binding box around that. And by doing that, it was able to identify. This is what object detection is used in autonomous driving, that the cars can see what are the objects in front of them. So then it said it's a potted plant. Now, key deep learning application areas. So I created this just to show you where all the research is happening in deep learning, and what are the key areas and where applications are. So the first one is computer vision. There's a lot of work that's done in computer vision. I just showed you an example of image recognition. So image recognition is also like facial recognition used by Facebook. Then object detection also was in the video, the bounding box. And in fact, in this very example, you see the bounding box this is from the autonomous driving, a self-driving car. And it will see a car or a signal in front of you, and it will identify that this object is a car, this object is a signal, etc. The next one is natural language processing. A lot of research done in that area as well. Machine translation, text classification, all of these are there. Content suggestion, I gave you an example of Taboola. recommendation system. Another very hot area that's getting a lot of interest. Speech to text. This is an example that I'm showing in this picture is Alexa. Text to speech. Triggered word detection. So in this case, when you say, OK, Google, it wakes up that engine and then starts to perform. And finally, reinforcement learning. That's an area of a lot of research. This is a little bit different than your typical supervised, unsupervised learning. And it's used in robotics and games. It's a little, the way it works it on reward-based system based on what's changing in the environment without a need for a lot of label data. So these are the key areas where deep learning is making a lot of progress. And these are the ones that are being used in applications. So how to get started? As I mentioned before, that there is a lot of open source work that's happening. So this is a portfolio of Intel, and it has a very broad portfolio. So let's start at the bottom. So at the bottom is a list of hardware that Intel has. So we have data center, we have general purpose CPUs, we are building deep neural network processors, we have FPGAs. So depending on what the customer wants, whether latency is important, performance, so we have the hardware. On top of that, you have the software. Depending on the user, if it's a library developer, we have compilers. So we build these software. And then in the middle row, at the right, you see the deep learning frameworks. So these are open source frameworks. So for example, TensorFlow, developed by Google, MXNet, developed by Amazon, Caffe2, PyTorch by Facebook. So my team works with all of these companies very closely because we are basically optimizing it so that it works on Xeon. So my point of showing this is that there is a lot of collaboration happening. All of this is open source, especially in the area of AI and deep learning. People are putting their models on GitHub. Like my team has lots of trained models. We're there for anybody to use. And papers are being put in archive. So you don't need to start from scratch. Look at the resources that are already out there. Use that. Use examples. Take advantage of that. So here's a resource that you can use, software.intel.com. There is a lot of tutorials. There are tools. There are webinars. And take advantage of that. And similarly, there's a lot of it available. So take advantage of that, learn, and use it. So I have 5 minutes left, and hopefully I'll try to wrap it up. So AI for ethics and social good. So now, like any other powerful tool, there are some downsides, there are some things you need to think about. And one of the key limitations of AI is bias through data. It's been in news a lot, and rightly so. So bias through data means, you saw the concept of training, right? So if the training data that you're entering is biased, the output of your model is going to be biased as well. So it's garbage in, garbage out. And so these are some examples which just happened recently. Loan approvals. So these loans were rejected for certain minority ethnic groups. Why? Because the model took in data which showed only certain people as being successful, and those are the good people that to give loan to. Similarly, hiring tool. This major company in the US had to shut down its AI-based hiring tool because it was biased. Again, it was biased against women. Why? because the data that was fed in as successful potential people, candidates, were men. And so it rejected applications for women, and that created a lot of issues, and they had to shut it down. Chatbot, another example, major software company in the US. They had a chatbot which was learning from what people were feeding in. People started saying all kinds of rubbish things, and it started spitting it out. So limitation of if the data is bad, your model is going to be bad. Adversarial attack. If you look at this stop sign here, to you, it's a stop sign with a sticker. So researchers in Berkeley proved that to a human, what may seem like a stop sign with graffiti, a computer vision model in autonomous driving, self-driving car could not recognize this as a stop sign. It thought it's something else. And so that can lead to very dangerous consequences, because adversarial attack means changing, it's an attack on an AI system to make it do something that it's not intended to do. Okay? Similarly, deep fake, it's to synthesize video of making somebody do something which they never did. In this case, President Barack Obama is saying something which he never did, and this was put up on the website by BuzzFeed, and they were very clear about it, that he didn't say it, but we are proving a point. So you can see how dangerous this can be as well, right? So, so what are the solutions? And again, this is a very hot area, a lot of research happening, a lot of people working to make this right. And inclusive data is obviously one of the very obvious things to do, easier said than done. But if the data itself is all over the place and biased, then you need to make an attempt to make sure the data is correct. Explainability. So these deep neural networks are like black box that you feed in data, it just figures it out, and then it gives you prediction. But now explainability is being added so that this data is understood. If the bank loan was refused, why was it refused? Was it because the credit wasn't good? Was it because this person lives in a bad neighborhood? Or what is the problem? So that, and finally this link that I have here are these ethics tools, toolkits. There are many, many toolkits. Many universities, companies are making sure that their tools exist, which have checklists and which are trying to make these models work. So just a few more minutes left. AI for social good. So this is something I'm very interested in. My colleague, Anna Bethke, is leading this at Intel. And we are trying to do, make sure that the technology is used to do some social good. And I only have like half a minute left. So let me try and make this fast. I have some examples of the projects that we are involved in social good. I'll try to do it quickly. This was actually, I put in here because this is with World Bank. And in this case, the purpose was to create a data set which is clean, to remove personal information, categorize it. So this was a collaboration with the World Bank. This is clean water. So based on pattern recognition, that the laptop has an Intel VPU, vision processing unit, and a microscope connected to it. And by looking at pattern recognition, it would say if the water has bacteria. And if it does, then that water is considered not clean. Great Wall of China. It's 20,000 kilometers long, but there are shortcuts also. I climbed it. So we have our drones that actually take very high resolution picture of the damages. And then we make a 3D model and figure out what the damage is and how much it's going to cost, and compute all of that, versus imagine a person climbing and finding out every which way to fix. This one got a lot of attention because this was in collaboration with Leonardo DiCaprio organization. So in this case, again, we are using the object detection model where it's connected to motion sensor. And if we with the vision Morvidius VPU, and if we see that with the bounding box that if it's a vehicle or a person, we send that information to to rangers, and warn them that it may be a potential poacher, and then they react to it. And my last example here is maximizing mobility. So this is our collaboration with Whobox, and here we are using facial gestures using the 3D Sense depth cameras and our inference engine, OpenVino, and making it possible for patients with spinal cord injury to use facial gestures to move the wheelchair. And it says time is up, and I'm going to leave you with these three key thoughts, takeaways. The one is that AI is advancing rapidly, and it's poised to remake the world. But beware the hype. Some of it is unfounded. Some of it, like job disruption, is indeed something to think about. Learn to leverage. You don't have to start from scratch. There is so much work that's already done. Take advantage of that. And finally, use in an ethical way. So understand the limitations and use it to uplift mankind. Thank you very much.